been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, this is chapter 6, part 3. We're going to look at dilations and application of similar figures. So a dilation is when you enlarge or reduce a figure by a scale factor. And so I have a rectangle here, rectangle A, B, C, D. You can see the coordinates, so you can plot this in your notes, get some graph paper and make your notes look like mine. And what we're going to do is we're going to dilate this rectangle by a scale factor of 3/2. When you look at that scale factor, you notice that it's greater than 1. If the scale factor is greater than 1, then the figure will get bigger. If the scale factor is less than 1, then the figure will get smaller. So the way that we are going to do this is we are going to simply multiply the coordinates, each coordinate A, B, C, and D, by the factor of 3/2. So we have to multiply both the x and the y. This is a dilation about the origin, which makes this a little bit easier. So here we go. 4 times 3/2. 4 times 3 is 12, divided by 2 is 6. So we're going to call this A prime is going to be 6 comma, and then 2 times 3/2. 2 times 3 is 6, divided by 2 is 3. So 6 comma 3 is my A prime. And so that would be right here. So this is A prime. All right, and then my B prime, 0, 6. Well, 0 times 3/2 is still 0, so that's still going to be 0. 6 times 3/2, just to show y'all what I'm doing here, 6 times 3/2. 6 times 3 is 18, and 1 times 2 is 2, and 18 divided by 2 is 9. So B prime will be 0, 9. I'll plot that in a second. C prime, 6 times 3/2 is, well, I already did that. I just did that with the y value, so that's going to be 9. That's the x value. And then 12 times 3/2, 12 times 3 is 36, divided by 2 is 18. So 9, 18. And then D prime is going to be 10 times 3/2 is 15. And 8 times 3/2 is, 8 times 3 is 24, divided by 2 is 12. 15, 12. So now I'm going to plot these points. So 0, 9 is right here. That's B prime. C prime is 9, 18. C prime is way up there. And D prime is 15, 12, which would be right here. So then I can connect my dots. So as you can see, I've created a larger rectangle. It's been, ABCD has been dilated by a factor of 3/2. So 3/2 is the same as 1.5, 1.5. So A prime, B prime, C prime, D prime is 1.5 times larger than the original A, B, C, D. Just real quickly, I want to remind you that the perimeter is going to have the same factor of 3/2. And you have to notice that the A prime rectangle coincides with the 3, and then the original coincides with the 2. And then the areas, remember, will be a factor of 3/2 squared, which would be 9/4. So that's the ratio of the areas. All right, let's take a look at this problem, and I'll explain what it is. So we have a situation here. We have a flagpole, and we have a man standing, next to the flagpole. And this is creating similar figures. And so the question is, we have to figure out what is the height of the flagpole. So we know the height of the man is 5 feet, and we know that the man is 6 feet away. So his shadow is 6 feet long. So this right here is his shadow. And so we have similar figures created by his shadow and the flagpole. And so we can sketch a triangle here and talk about the similar figures. We also have a triangle created by this man and the shadow. And so we need to figure out what our ratios are that we can set up and in order to find the height. And so the height of the man corresponds with the height of the flagpole. And then the next ratio would be the distance of the man's shadow, which is 6, which that is going to correspond to this entire length of the flagpole, or the flag at the top, casting down all the way past the man. And that total is 18. So that is the proportion that we're going to set up, and then we are going to solve. So 18 times 5 is what we're going to do first. 18 times 5 equals 6h. 18 times 5 is 90 equals 6h, and h would equal 15. So the height of the flagpole would be 15 feet. So that's how you can use similar figures in problem situations, and we will do some more of those in class.
I've been waiting way too long.